Subscribe to my channel to get alerts on new videos on data science.
Hello friends, as we all know, numpy is a very powerful tool in creating ND arrays. Having known about the methods to create the arrays and generate values in them, it's high time we understand the various sorting mechanisms on the array values. And in this video, I'll be covering some of the methods like sort, argsort, legsort and partition to sort the array values. The very basic sorting method is to use the sort function. Let me explain you on how to use the sort function on the arrays. First, let's check on the 1D arrays. So in this example, I have a 1D array which is ARR1 where I have values like 5, 2, 7, 8, 6, 1 and I want to sort this array, for which I'll be using this sort function. I'll just give sort of ARR1 which is going to return me the sorted list of values. Sorting the 1D array was pretty much simple. So you would be wondering how it will work on 2D arrays. So for sorting on 2D arrays, I'm first generating the values using the random function where I'm creating a random list of values with 3 rows and 5 columns. So this is going to be my array ARR1. So first I'm printing this array. So that is why we are seeing this in the output window. So next I'm going to sort this ARR1 where I'm going to give sort of ARR1. So what exactly happens here is that while sorting 2D arrays, the first row will be considered and the values in the first row will be sorted, and that is going to be the sorted result of the first row. So here in my example, I have 0.569, 0.954, 0.219, 0.154 and 0.886. So my first row in the sorted array is going to be, the least of it is going to be 0.154. So that is going to be the first value, followed by 0.219. Then we have 0.569 and then 0.886 and then 0.954. So each and every row will be considered separately for sorting the values. So this is going to be the sorted value of the first row, and the next row will be considered and the values there will be sorted, and that is going to be the second row of the sorted array. So that is how sort function works on 2D arrays. The next sort function that we have is the argsort. So this sort does not return the sorted values, rather it returns the order of indices which is going to point to the sorted list of values. In simple words, argsort is going to fetch only the index values and using which we can generate the sorted list of values. The shape of this particular output is going to be the same shape as that of the array. So consider this 1D array where I have the values 3, 6, 2 and 4 in the array ARR1. First, I am printing the values of ARR1, which is going to print me 3, 6, 2 and 4. So next, when I am going to call this argsort function on ARR1, what it actually does is it is going to return me only the index value. So the output is 2031, meaning the second index is 2, the 0th index is 3, the third index is 4 and the first index is 6. So the sorted values are going to be 2, 3, 4, 6, and this argsort is going to return the index values of 2, 3, 4 and 6 in the same order. Now let us consider this 2D array where I have 3 rows and 3 columns, and the values are going to be 4, 7, 3 in the first row, 2, 1, 9 in the second row and 1, 5, 3 in the third row. And the index values are going to be 0, 1 and 2 respectively. So first I've printed the values of ARR1 and that is why we are seeing the array in the output window. Next, I'm going to call this function argsort on ARR1. So the values are returned like this, which is 201, 102 and 021. So what does that mean? 201. So the value of the first row with the index value 2. So 3, 0 is 4 and 1 is 7. So the sorted list of values are going to be 3, 4 and 7. So this arc sort has returned me the index value of 2, 0 and 1. So similarly, the arc sort is applied on the second row of the 2D index. So the value is going to be index value 1, index value 0 and index value 2. So that is why we got 1, 0, 2 here. So there is another parameter which I can pass here in arc sort, which is the axis value. If I give the axis to be none, then the array is going to be first flattened and then the sorting will be done on the flattened array. So here it's a 2D array with 3 rows and 3 columns. If I don't give the axis value, the sorting will be done on each row. But since I've given the axis to be none, the array was first flattened where the 2D array became the 1D array and then the sorting was done on that. And that is why this arc sort is now returning me the index values of them. If I first flatten this array, it is going to be index 0, index 1, index 2, index 3, index 4, index 5, index 6, index 7, index 8. So the arc sort is going to return me the list of indexes on the flattened array. So first it's going to be index 4, so which is index 4 followed by index 6, followed by index 3, followed by index 2, and then index 8, followed by index 0, and then index 7, index 1, and index 5. Say I'm going to give the index value to be 0. So in this case, sorting will happen along the axis in the vertical direction. So we have the first vertical axis to be 4, 2, 1. So arc sort is going to give 2, 1, 0 because this is the least and then we have 2 and then we have 4. So 2, 1, 0 is going to be the first output. Next we have 7, 1, 5. So it is going to be 1, 2, 0. And that is why we got 1, 2, 0 here. Similarly, we have 3, 9, 3. So we have 0, 2 and 1 as the result of this arc sort. If I give the axis to be 1, then the sorting is going to be on the horizontal direction. So we have 4, 7, 3 here as the first row. So the sorted result is going to be the index value 2, index value 0 and index value 1. So next it's going to be 1, 0, 2. Similarly, 0, 2, 1. So this is how the axis equal to 1 works on 2D arrays. Say I have got 2 arrays with me and I want the sorting to be done based on the array order that I provide. So in that case, I can use the leg sort. Consider this example where I've got 2 arrays ARR1 and ARR2 and the shape of the array is the same where I have 1 row and 5 columns and these 2 arrays are 1D arrays. So in the third array, which is ARR3, I can give the leg sort on ARR1, ARR2. So what actually happens is this sorting will first sort the arrays based on ARR2 and then based on ARR1. I'll explain you how this leg sort works. So next I'm going to give a print statement where I'm going to print the sum of ARR1 of I and ARR2 of I. The sorting is going to happen first by ARR2 and then by ARR1. It's going to be these two ones followed by 3, followed by 6 and then followed by 7. So next it is based on ARR1. So the combination is going to be 1, 5 first, next it is 1, 6, then it is 3, 6, followed by 6, 2, followed by 7, 3. So leg sort is going to consider these two arrays as two linked arrays, and that is why we give the order in which the arrays have to be sorted here. First it's going to be 1, 5. So if I add these two, it is 6. So we have got 6 printed here. Next it is 1, 6. So sum of these two is 7. So 7 got printed here. Next, it is 3, 6. So 9 gets printed here. Next, it is 6, 2. So 8 gets printed here. And then finally we have 7, 3. So the sum of these two is 10. So 10 got printed here. And this is how LexSort works on two different arrays, provided the shape of the arrays should be the same. Let me show you another example on how LexSort works on first names and surnames. The mapping are the first surname and the first name, the second surname and the second first name, and so on. If I'm going to print the list of surnames and first names in the sorted order, all that I have to do is call this LexSort function on first names comma surnames. So surnames is going to be first sorted and the next sorting order is going to be on the first name. The first value is going to be Hertz and the next sorting will be on first names. So I have Hertz Henry and Hertz Thomas. So the first value is going to be Hertz Henry, the next value is going to be Hertz Thomas, and the third value is going to be James Henry followed by James Thomas. So this is how the LexSort works on two different arrays, provided the shape of the array has to be the same. Next, let's get into the partition. I'll explain this partition method with an example. So here I have a 1D array which has the values 7, 1, 5, 2, 3, 2, 0, 1 and the name of the array is A. I'm going to call this partition function on this A and I'm going to pass the value as 2. The values of my sorted array will be 0, 1, 1, 2, 3 and it will keep going. So the value in the second index position is going to be 1. The way this partition works is whatever value that is expected to be in the index value of 2, which is 1, is going to be there in the index value of 2. Index value of 2 is going to hold the value of 1 and all the elements before this index value is either going to be less than or equal to this value and all the elements after this index value is going to be either greater than or equal to this value. And this is how the partition works. Now let me explain you with another example so that you can get a clear understanding on how this works. Here I have this 1D array A which is going to hold these set of values and then I'm going to call the partition on A and then give the value to be 1. So the value in the index value 1 is going to be 1 because first we have 0 followed by 1. So that is the next number as per the sorted order. So this 1 is going to be present in this particular index value 1 and all the elements before this index value is going to be less than this value. So it is 0 and all the elements after this index value is going to be either greater than or equal to this value. So consider this example where I have given partition of A comma 3. So the values are 0, 1, 1, 2. So 2 is going to be in the position of index value of 3 which will be in the sorted order. So 2 will be first placed in the index value of 3 and before this index value all the elements will be placed such that the values will be either less than 2 or equal to 2. So in our case we have 0, 1, 1. So all the values which are greater than 2 or equal to 2 will be placed after this index value of 3.
Hey guys, hope you have understood about some of the sorting functions that we have in numpy.